Today is day number 8 of our Dragster project, and today you are going to test out your Dragster. You are going to collect or copy Dragster data and then calculate velocity and some averages of the data that you collect. If you are able to test out your Dragster and actually run it on the track in the classroom, your teacher will go through all of those directions for you. If you're not able to test it out in the classroom for whatever reason, that's what we're going to go through here. I'm going to give you some data that you can copy down for 2 different Dragsters that I had created, and give you that data so that you can calculate kind of the velocity and those averages from that data, and then use that as we're kind of drawing some conclusions. All right, and so our essential question today should be, or is, how are speed and velocity calculated? And so we need to understand speed and velocity, and then just how we calculate it, how we do the math to get those answers. All right, so right now let's open up our design notebooks and pause the video to do that. All right, we've got our design notebooks open, and again we are on day number 8. So if you are in the classroom, you are going to race and test your cars. That's what you're going to do in the classroom. And then as you are racing those cars, you're going to collect some data. Either way, even if you are not in the classroom or you're not able to race your car, I'm going to give you some velocity data then that you can use to calculate the velocity and some other information about that. All right, so let's click on the bookmark for day number 8. That drops us down to the beginning here. As always, we want to set a goal for ourselves. What do we want to do? That gives us something to work towards today. Our essential question, how are speed and velocity calculated? Calculating is just determining the amount or number of something using math. So we're going to be doing some math today. If I can't remember what speed and velocity are, I can click on this bookmark, and that will just take me right back up here to our vocabulary. So you can go back to those definitions from the first day of this project to remind yourself of what speed and velocity are. All right, I'm just going to go up here, do this the quick way, go back to day number 8, click on that bookmark right there. All right, so the Dragster data. You're going to enter data into the table below. If you are in the classroom, again, you're going to use a scale to calculate the mass of your Dragster, the weight of your Dragster, and we're calculating mass in grams. That's what we are going to be using. Make sure that you include the wheels and the axles in your measurements as well. So if this is the Dragster that you created, you want the wheels and the axles as part of that, because that is part of your car. And so we have a, just as a reminder right here, the formula for figuring out velocity. As you recall, our definition of velocity and speed is the relationship between distance and time. How long do I go in what amount of time? And so to calculate velocity, we take the distance, and in this case we're going to measure that in inches, and divide it by our time, how long it took us to get to the end of the track in seconds. All right? And so that's going to, and I'll remind you of that here in just a second, that is the formula for velocity. So then we get down to our chart. And so we are going to, I'm just going to look over here on the left-hand side first. We're going to enter our data into this chart for each of your Dragsters. Hopefully you were able to create 2 different Dragsters. Okay, one out of plastic, okay, on the 3D printer, and then one using the shop tools out of wood. All right. So you're going to calculate the velocity of your 5 trials. So you're going to test this out and race each of these cars 5 times. And then you're going to calculate the average for mass, distance, time, and velocity, those 4 data points that we are going to collect. And so in this chart here you see mass, distance, time, and velocity. Mass is measured in grams. That's what the G stands for. Distance is measured in inches. We're measuring this in inches. And the time, we're measuring how long the car takes to get to the end of the track in seconds. So then velocity, because we're inches divided by seconds, our velocity is measured in inches per second. So now if you are in the classroom and you are able to race your cars, you're going to use a scale to measure the mass of your car. You're going to, I will tell you here in just a bit, the distance. Or in class, you'll find out the distance in inches of the total track. You're going to use a stopwatch to measure the time, how far it gets from when it starts to the end of the track or when it stops. and then ultimately you'll do some math and calculate velocity. If you are not able to race your car in the track, right now what I would like you to do is I would like you to add this data into your chart for your plastic car. So this was data that I took when I was actually able to race my plastic car, the 3D printed version of this Dragster, on the track in class. And so you can see the mass was 55.62 grams, and that included the wheels and the axles. Notice that the mass never changed. Now, if I have a Dragster and I race it once, and then I go and maybe I change the shape of it, or I, cut some materials off, maybe I wanted to just take a snip and kind of cut the corners off for whatever reason, well, that would change the mass, and so I would need to reweigh that. However, for this particular car, I didn't make any changes. So the mass was 55.62 grams every time that I raced this car. The track that we have in class is 270 inches from the start to the finish. And so this tells me that when I raced my gray 3D printed car, that it made it all the way to the end of the track. So it went 270 inches. The times were different, so it wasn't the same time each time. So the first time I tried this, it took 1.16 seconds, and it was 1.07 seconds, 1.24 seconds on the third try, 1.19 seconds on the fourth try, and then 1.32 seconds for the fifth trial. So now what I need to do is I need to calculate velocity. So I did this first one for you. So the velocity of the first time, how fast was my car going down that track in that straight line? It went 232.76 inches per second. So to figure that out, I did 270, right there, divided by 1.16. Okay? So for the next one, I'm going to use my calculator. I'm not going to try to do this in my head. I'm going to figure out what the velocity for my second trial was. 270 divided by 1.0. So go ahead and pause this video right now and see if you can calculate what that velocity was. Once you have the velocity for attempt number 2, you're going to do the same thing for number 3, 4, and 5. And so all of these columns should be filled in with the velocity of the cars on each of those trials. Then we come to average, and we want to calculate the average of each of these columns. What's the average mass, distance, time, and velocity? So to calculate the averages, I'm going to pause this video here and put up another screen that's going to remind us how to calculate average. So here we go. To calculate average, we're going to take the sum of all numbers divided by the total numbers that we added together. For example, if I have these data points right here, 13, 16, 18, 11, and 20, how do I calculate the average? First, I'm going to add all those numbers up. So 13 plus 16 plus 18 plus 11 plus 20, and that all equals a sum of 78. Then I'm going to take that 78, I'm going to divide it by the total numbers that I added together. I had 5 numbers that I added together. So 78 divided by 5 gives me an average of 16.5. All right, so this would be a good time to pause this screen now and finish calculating those velocities for the plastic Dragster trials. I misspoke there a second. I said calculating the velocity, but we're actually calculating the averages. So what you're going to do then is you're going to add up all of these right here. You're going to get a sum, and you're going to divide by 5 because you had 5 numbers that you added together. You're going to do the same thing for 270 inches. The car went all the way to the end of the track all 5 times, so add those up, divide by 5, and get your average. Add all of these times up, divide by 5 to get your average, and then do the same thing for the velocities to get your average. If you have further questions about that, go back in the slide to see that reminder slide, or go back in the video to see that reminder slide to calculate those, or reach out to your teachers and we would love to help you. Okay, then we get down to the wood dragster. So hopefully you were able to also create a wood dragster. So we've got 2 different dragsters that we created. If you were in class and you're able to actually test this out on the track, you're going to have, using the scale, you're going to have, again, your mass. You're going to have the total distance that it made towards the end of the track. The time is measured on the stopwatch from the time you started the car until the end, until it stopped or made it to the end of the track. And then you're going to use that information to calculate velocity. If you were not able to test your car out for whatever reason, okay, some data, right now you can pause the video and enter that data into your chart so that you can calculate velocity as well. So pause the video right now and enter this data into your design notebook. Now that you have that data, you're going to do the same thing that we just did above. So calculate the velocity, distance divided by time. You can see that all 5 of the times that I tried out my wooden dragster, it made it to the end of the track, so it went 270 inches. You can see the times, 1.09, 0.96, 0.88, 1.12, and 0.92 seconds. So you're going to use that, again, distance divided by time to calculate velocity. Once you have velocity calculated for all 5 trials, you're going to go down and calculate average. And you'll do that the same way that you did for the above chart for the plastic car as well. What was the mass? Add all those up, divide by 5. Same thing with the distance, the time, and your velocities to calculate your averages. This is important information because we're going to use that next time as we reflect and think back about what are the differences now between our wooden car and our plastic car, and try to explain some of the differences. Why are there differences there? Once you have all this information in your data chart, you have a summary to complete today. Write what you accomplished and what you learned today. Okay, make sure you complete that, and then you see the stop sign, the end of day 8. So at this point, you can finish up that work. If you have questions, make sure you reach out to your teachers, and we would love to help you with this. But make sure you collect data. Have fun racing your cars. And if you're not able to race your cars, hopefully you can get all this data and these questions figured out in terms of which one of these went faster. You know, was the plastic car faster or was the wooden car faster? All right, so reach out to your teachers if you have questions, and we will see you in class next time.